So our first swing is 2 feet, and every swing after that is 0.9 of the previous length. So basically 0.9 times the previous length. So the next one is 0.9 times 2. And then our next one is 0.9 times that. So it's that times another 0.9, right? And then it's this times another 0.9, and so on. And so I'm not going to bother figuring those out, but I can definitely tell that it's geometric because I'm multiplying by the same thing every time. I'm multiplying by 0.9 every time. And so if they want to know the length of the 10th swing, I want to know, this was my first swing, second swing, third swing, so I could just keep going. But we have formulas for these if you want it. And so I'm going to send you this link. Let me get to it. All right, so this is on my bulletin board. These are all the formulas that you're going to need for arithmetic and geometric sequences. So for a geometric formula, you're going to start, for a geometric sequence, you're going to start, with your first term, and then multiply by your common ratio n minus 1 times. So if I do that here, to get any term I want to start with the first term and multiply by my common ratio n minus 1 times. So if I want my 10th term, I'm going to start with the first term and multiply by my 0.9, 10 minus 1 times, so 9 times. And so then I'm going to get 2 times 0.9 to the 9th. Make sure you do 0.9 to the 9. Either you punch it in all at once or you do 0.9 to the 9 first and then multiply by 2. Got to obey Aunt Sally. And you got 0.7748, and that will be the length of the 10th swing. So now, what else did they want? Go back. Okay, so now they want, when's it first less than a foot? You're kind of, by the 10th term for part B, you're already less than a foot here, so you'll hit it up until then. You could do like logs to solve it, but I would probably just try to guess my way there. So what if it were at 8 and you just figure that out? And it's like, is it less than a foot yet? Oh, okay. So I'll let you handle that. Oh, no, we can try it. So like, let's say we try 8. That'd be the first term, 0.9 to the 7th. So if I punch that in on my calculator, I get 0.9565, and it is less. And so I'm wondering on the 7th term, was it less? Let's find out. So it was still more than 1 on the 7th. So you needed to go to the 8th term to be less than 1. So by the 8th swing, it's less than 1. So that's that. And then for part C, they're asking what will the total length be? So if you want the total length that it swung, well, the first one it swung 2, then it swung this, then it swung that. So you want to add these. So if you're adding them, you've got formulas for that. So I'm going to go back. Whoops. Back and forth. So I'll send you this picture again. And so now if we want the sum, your sum of the first n swings is your first term times 1 minus r to the n over 1 minus r. So if I want the sum of the first, I forgot how many they said. Sorry. So they want the sum of the first 15 swings. So that's just my first term times 1 minus my r was 0.9 to the 15 all over 1 minus r. So if I punch this in on my calculator, just be super careful with parentheses. I'm going to do 2 parentheses, 1 minus 0.9 to the 15th, and then divided by parentheses around the bottom, or just simplify that right away to 0.1. I get about 15.88. Check. And then when it stops for part D, it kind of has to swing like an infinite number of times before stopping. Kind of weird, but your formula for it stopping is actually easier. Your infinite sum is just this without that part. So it's just a sub 1 over 1 minus r. The formula is easier, but it only works if you're multiplying by a number less than 1. If you're just getting bigger, there's no way you're going to add up to anything pretty. So we're just going to plug that in, just 2 over 1 minus 0.9. So 2 over 0.1 is 20. And that's that guy.